Alright, so now we're going to continue on with part 2. We're going to start off on number 13. It says a figure lies in quadrant 2 of the coordinate plane. The figure is transformed by first reflecting across the y-axis and then rotating 180 degrees about the origin. What quadrant will the image lie? So basically all this is we have a figure that's actually drawn on here, but we're really just moving it. So we got to figure out where we move it to. So if we do a reflection over the y-axis, we're flipping over the y-axis. So it ends up moving into quadrant 1 to begin with. But we're not done with it there, because after we've moved it to quadrant 1, we want to do a rotation of 180 degrees clockwise. So again, we can turn our paper 2 to the right to get it that way. And if we turn it 2 to the right, it actually moves 1 quadrant, 2 quadrants that direction. So it ends up being located down here in the bottom left. Now, this problem actually is very nice to y'all and gives you the actual quadrant numbers in the corner. Granted, you should know these already by now, right? But we're going to go ahead and say that our answer is quadrant 3. Number 14 is a construction problem. Right, so it says, which of the following best describes the construction? We have this picture here. Right, notice that we have the arcs coming from here. So those actually were centered on Q and P. So if you remember the constructions, this one actually represents the perpendicular bisector. Now what happens with this is that we know it's the same distance from P as it is from Q where it meets, and we have it 90 degrees. So we know it's a perpendicular bisector, so we kind of are going to eliminate A and D, but we now have to know which one's being the bisector and which one's being bisected. So if we notice, AB is coming through and cutting PQ in half. So what would be the actual correct answer would be that AB is the perpendicular bisector of PQ, since PQ is the one being cut. And the perpendicular bisector actually cuts that one in half. So since AB is not necessarily shown to be cut in half, that's not the one that would be the bisected one. Number 15 has triangle ABC with vertices 3, 1 for A, 4, 5 for B, and 2, 3 for C, being reflected across the y-axis and then rotated 90 degrees counterclockwise. So basically on this one, you're going to have multiple choice. You figure out which one it is off of those ones. But since we don't have the luxury of the multiple choice on this part, we're actually going to look at it and do it the right way. So if it's over the y-axis, we're going to notice C is 2 to the right. We go 2 to the left for C prime. B is 4 to the right, so we go 4 to the left for B prime. And then A is 3 to the right, so we go 3 to the left for A prime. I accidentally put double primes for some of those, but it's just used 1 prime. Alright, so the next step on this one is actually to rotate it 90 degrees counterclockwise. So on this time, we're going to take it and turn it to the left. So when we do that, C ends up getting moved to -3, -2. So there's C double prime. B is at -5, -4. There's B double prime. And A is at -1, -3 for A double prime. Connect those dots. And again, you should be able to actually kind of see which one it ends up working through whenever you're actually looking at the problem. Just the answer choices. Alright, number 16 is another proof. And when you actually look at the entire thing, all it's really asking for is what is the statement in step 2. So we're only really worried about the blank spot here. Notice that the reason was given. So there was only 2 things that we were actually given in this page. So we have AC is the shortest segment of A to CD, and that measure of angle M is equal to measure of angle 2. Measure of angle 1 is equal to measure of angle 2. Notice that measure of angle 1 equal to measure of angle 2 is the statement for step 1. Therefore, the other given has to be the statement for step 2. So all we're really going to have is that this goes here, which means that that's what we're looking for the answer. So again, it's kind of multiple choice. Use that to your advantage. Figure out those values. Alright, number 17 has quadrilateral ABCD as a square. It uses slopes to prove that basically AC is perpendicular to BD. So we're wanting to show that these are 90-degree angles here. The way that we do that is by slope formula. Again, it tells us that. So the slope formula is y2 minus y1 over x2 minus x1. And again, it doesn't matter honestly if you have y1 or y2 or which one you pick. You just pick a x and or y. That goes first, and whichever one you pick first goes first on the bottom as well. So we really have to worry about what these ordered pairs are. So if we look at A, it's at 3, 9. B is at 10, 8. C is at 9, 1. And D is at 2, 2. So we're just really going to fill this one. We're using AC first. So AC, the slope that we're going to look at, we take a y, which I'm going to pick 9 first. So I'm using the y value on A, 9. I'm going to subtract the y value on C, which is 1. So 9 minus 1. Over, since I start off with the A, I'm going to start off on A on the bottom, 3 minus 9 here. So 9 minus 1 is 8. 3 minus 9 is negative 6. However, we need to reduce that to negative 4/3. There's AC. We need to also do BD. So BD, I'm going to start off with the 8 for the top. So that would be 8 minus 2 over 10 minus 2. Okay. Again, I went B to D. So 8 minus 2 is 6. 10 minus 2 is 8. Reduces to 4/3. Nope, sorry, not 4/3. That would actually be 3/4. So again, we actually want to do this. Notice that these are opposite reciprocals, meaning that one is positive, one is negative, and the fraction actually gets flipped. Okay, so when we do that, if they're opposite reciprocals, or if one is 0 and one is undefined, that proves that the lines are perpendicular. So this actually is enough to show that this is proof. Now granted, again, you aren't going to have a proof or something like that. You're going to, basically this is to hint that you're going to have to be able to do slope formulas to determine if something's parallel or perpendicular. Number 18 wants us to write an equation that is perpendicular to the line y equals 3/4 x minus 10. So again, perpendicular, we need the opposite reciprocal. So we look at the slope that we're given, 3/4. So 3/4, the opposite reciprocal is negative 4/3. So we're going to do y equals to negative 4/3 x plus anything. It does not matter what this is, it still works. Now the only exception to this rule is if it was saying parallel. If it was parallel, you need to have something that was a different y-intercept. But on this case, since it's perpendicular, it doesn't matter if it's the same y-intercept or not. Alright, problem number 19 says which lines, if any, must be parallel based on the given description. And then it wants to give us the justification for the conclusion. So it says 4 is congruent to 12. So 4 would be the same as 12. Now notice they're both in the bottom right, so this is corresponding angle. Alright, so looking at this, we notice that we have a transversal that is actually going through both lines C and D. So since those are corresponding angles and they're congruent and it's going through C and D, we can say that C is parallel to D by the corresponding angle converse. Okay, now, so again, it's basically just looking at which ones are being related and then figuring out if it's corresponding, alternate interior, alternate exterior, same side interior. It's going to give like a reason off of it. Alright, number 20 has a line passes through the points 10, 1 and negative 8, 5. What is the slope of a line that is parallel to that line? So again, we're just doing slope formula. We just need to figure out what this one is. So again, and we're just going to plug in. So pick a y, I'm going to pick 1, I'm going to subtract the other y, 5. 1 minus 5 goes over 10 minus a negative 8. Anytime you're actually subtracting a negative, it's really like addition. So we really have 1 minus 5, which is 4 over 10 minus a negative 8, which is 10 plus 8, so 18. Now both of these can be divided by 2, so we simplify this, and your final answer is negative 2 over 9. That would be the slope of a line that's parallel. As far as number 21 goes, we have to figure out which one of these are parallel. So the best way to do this is get everything in slope-intercept form, which basically means y by itself. So if you notice, 1 and 2 are already in slope-intercept form, so you don't have to adjust any of those. So it's really not a point in changing any of them. But let's look at 3 and 4. So if we notice those, y is not by itself, so we actually have to do some adjustments. So on number 3, we're going to subtract 12x from both sides. It gives me negative 3y equals to negative 12x plus 6. Divide by negative 3. Now, since there's addition on the top here, we actually have to kind of distribute this negative 3 to both of them. So we're actually going to divide negative 12 by 3, and we're also going to divide 6 by negative 3. Okay. Left side's y. Then we get equals to 4x minus 2. Alright, we're going to move on to the next one, and then we'll look at all of them and see which ones end up being parallel. But for this one, it's going to be divide by 4. So we end up getting y plus 6 equals to, we'll just say 1/4 x instead of having x over 4. That way we have a better idea. Minus 3/4. But again, y is still not by itself, so I'm going to actually subtract 6. Now, normally we would not write improper fractions, but we're really more focused on the slope of this. So y equals to 1/4 x, or not improper, I meant mixed, minus 6 and 3/4. So again, 6 and 3/4, we really wouldn't normally put a number like that into this, but again, the y-intercept's not important, it's really the slope. So noticing on this, right, 1 and 3 both have a slope of 4, so since those are both the same slope, they're parallel. If you notice numbers 2 and 4, one is negative 1/4, the other one is positive 1/4. That's not the same. Even negative makes a big difference, so those are not parallel to each other. Alright, and I think this is where we'll stop for this video, because again, it's kind of ties in everything else next. This is kind of another section.